Okay, so hi everyone. We're 2 minutes early, I think, but we're gonna start anyways because we have lots of stuff to talk about. Um, One of the things that impresses me most about Congress ever since I've been here is the crazy amount of infrastructure we have. And this year, with the biggest Congress ever, that's gonna be even more impressive than it already has been. We are going to have this combined presentation of every star OC thingy we have, and so different people are going to talk about different stuff. And we're going to start with the NOC review, so please welcome the guys of NOC and have fun.
Hi everyone and good morning. My name's Will Hargrave and this is Kai Reftin. We've been working on the NOC. I can't pronounce your name, but okay. So I came down here and there was a massive crowd of people outside this room, and I was wondering, wow, can I get in here? Should I maybe stay in the NOC with these kind of travel difficulties and just present over Skype? But anyway, here I am. So, for those of you who were here last year, we now have more of the CCH we're using. Now the backbone, you can't really see the diagram on here because the network got bigger as well, because the backbone got bigger because we're using more rooms in the CCH. That meant a bigger pile of equipment. We had, for the first time, we had two MX240s with Juniper MX240s with 100 gig interfaces for the uplink. We had a whole load of MX80s, which are smaller boxes with 8 times 10 gig each, and we built a whole load of 10 gig links around the building. Basically, the larger thicker lines on here are multiple 10 gig links. We also had an edge of Juniper EX, distribution really. For the first time, we also ran a full VPLS network in order to remove some of the layer 2 difficulties we had in the past. So that led to some more complexity, but it was in some ways easier for us to manage.
Yeah, last year you may have noticed a few issues because this year we have like doubled the infrastructure, because last year we had the Juniper X switches and used them also for routing as well, and that was a big mistake. So this year we placed on top on every switch, we had another big router, and which makes the network way more complex. So basically every room has now 2 big boxes which needs to be managed instead of 1. So that got way more complex, and yeah, that was the uplink graph. We had 100 gig to the data center, and from the data center we had a transit capacity of around 50 gigabits, and you guys only reached, I think, 40 gig in the peak. So why should we even build that big infrastructure if no one uses it properly? Yeah, this year's wireless, we had a different vendor which made some other things a bit more troubly. So yeah, these are the graphs. We had some outages a few times, but basically we had way more visitors than last year. I think last year we had 3,000 users in the peak. This time we had a peak usage of 5,000 users and 2.5 gig of traffic when I pulled the graphics out. And yeah, you may have noticed in the wireless we had an encrypted wireless running. That was basically an 802.1x, and you can enter any password you want and any user you want. And so the most people are just using 30c3 or guest, or yeah, this is just a small excerpt of the usernames with like penis, fplets, or fnord. And only 2 really elite hackers were available. And this year with the new GUI, we had really good eye on the airtime, which means the airtime is how much the 2.4 gigahertz band is used, or the 5 gigahertz band is actually used in the air. And this is a small graph from in the right corner of the airtime in Hall 1, so it was actually pretty used and busy. but most of the time it worked somehow. Yeah, we had some outages and problems during this event. On the day one, we had basically a big MPLS problem with unknown unicast broadcasts in the VPLS instances, and this stuff was going on the CPU of the routers, and we were debugging for like, I think, 7 or 8 hours to find out what the issue was. And during that, we discovered almost more power issues with one of the border routers where the wrong power supplies were shipped. So you basically have to plug in the right line cards into the right slots, else they just say, oh, I don't power up the line card. And we had also a little problem with ARP traffic from the wireless. There are like the big MX240, which has like a lot of CPU power, but obviously when the wireless came in and we had like, I think, 4,000 users on it, and then the box were like, oh, I'm turning on my back like seal and doing ARP, ARP, ARP. And speaking there, like doing nothing, and the box totally almost died. So we moved the routing for the wireless on a Linux box. Yes, we had like, I think, 3 or 4 million euros of equipment from the big vendor there where the half internet runs on, and then you can't do the routing for the wireless on the box because it's just fucked. Yeah, the colo this year was actually really good. I got there and I saw only 2 boxes where I said like, okay, these are really crazy because there was a SATA shelf next to the box, but not anymore like paper boxes with raspberries and USB disk in it with a power supply and a PDU, and it was way better. And on the left corner you see a small graph, we call it mean packet size. It's the average packet size on our uplink. Basically, when you make a complete FTP stream and just transfer big data, the packet size is really high and almost like at 1500 bytes. But if you go like, if you see the peaks like this on the 29th in the evening, there it goes really deep to like, I see almost 200 bytes per packet as average, which means there were people port scanning. And actually that port scanning stuff was really, really annoying. It's like, first, most of the people are filtering the Congress network anyway because it's just annoying. So it gets black hole and it's not a good view of the internet. And the other things, every port scan generates an abuse mail. And I typed these numbers an hour ago, and I had 653 mails, and I got like 60 more in the last half hour. And we got 20 abuse calls with people like, can you stop port scan? And it's nothing bad, but it's just really annoying because you have to tell them, no, a port scan won't break anything. And due to that, we actually had a big black hole list this year, and we black holed like 12/16 and 1/14 from the size, just to keep users quiet because they were really annoyed from the port scan when there's like every minute doing a complete port scan of the network from tons of IPs. And I think there was like only one real abuse incident where it was not a port scan. Yeah, and as usual, a small slide about our sponsors, because without them, it wouldn't all happen. And yeah, big thanks to also our upstreams which were not properly used from you, like Atrato, KPN, Arbone, and Kaya. And the network came from Juniper this year, the service from Babil, and we got the NAT64 boxes again from A10, which was used with like 15 people, which was really, really bad. Because that's actually what's going to happen in the next year when you don't get V4 address anymore. So you should test that. And yeah, also big thanks to the data center where we actually shipped all the hardware to, and the uplink terminates. It's IPHH here in Hamburg. And yes. And we have one more surprise for next year. As I got complaints, next year the complete NOC will resign, and we will do this from 3 systems, C3 systems, because someone complained it should be done by professional, and we thought, no, we are only working in NOCs for our whole work day, so we are not professional enough. We will outsource this next year. It will be much better. Yeah, and I think we are finished here, and the next presentation would be of the power team. And yeah, do you have any questions regarding the NOC?
What was the average bandwidth of the colocation?
Average bandwidth collocation was
Peaked at 18.
peaked at 18. We upgraded the link to 30 gig, but was mostly between 15 and 18 gigabits.
So if you have questions, please move to one of the mics so people in the stream and the video recording can hear what you're asking.
Do you have any more information about the outage yesterday in Saal 1? Because there was a tweet that something was manipulated. Do you have any more information on that?
Network equipment doesn't run without power, and when we went to look at the switch, there was not a power lead in the back of the switch.
Thank you.
Why do you think the NAT64 usage was so low?
I thought I'd got away then. Sorry, what did you say?
Why do you think the NAT64 usage was so low?
People end up using the internet for network connection for doing things, and actually, well, there's perhaps people get there and they may be doing other things. They're less interested in just trying things out. But we do try and encourage people to do experimental things or new things on the network. So it's available there for your use. Otherwise, I don't really know.
Thanks.
Yeah, so this year I will talk to you about the power team. We are driving the power supply here in the building. That's our used material this year. So you see it's about 15 kilometers of cables we have laid down here in the building. About 100 distribution boxes for 3-phase power and about 700 to 800 multi-power outlets. Everything we have to build here in this building new because it's a very old building. That's an example from the team from this building here that we get. And you see every power connection inside of this building. So there are only big power supplies and not so much normal power supplies for the users. And when we are doing this, it looks after this like this. That's the plan from the Erdgeschoss here. And that's room 3 with very much power supplies. The co-location this year was not really used from my side of view because I've put there 63 amps power supply and only 20 amps were used. So it must be a really good green IT what you have here. And on the whole 4 days we have 100... So that's the power consumption of this whole building in the 4 days we were here. And the normal power supply from one house with 5 people are up to 7,300 kilowatt hours per year. So it's a little bit more. That was the only numbers I can tell you because we don't have much more graphs or something.
Good afternoon. I'm Beth from the phone operation network. You may have noticed people running around with these phones. We're doing this in a joint venture with the GSM people, who apparently are not awake yet, some of them. Okay, let's start with a confusing graph. This is our routing plan. You can see at the very top a commercial grade PBX, we just call it 4400. Okay, all the DCT phones run from the 4400. It's connected to LCR, which is the Linux core router piece of software. That in turn is connected to a Yate VoIP server and that's connected to SIP. So in case you forgot your DCT phone, you could have connected via SIP as well. We are running one Asterisk server in the upper left corner over there for historical reasons, and several more LCRs. For example, for dial-in, dial-out, it was possible to dial out to the whole world, actually. No one noticed. And it's not always the case, but this year it was. It was possible to dial the GSM, of course, and a few special services up there. Okay, a few more statistics. We've had 2,800, roughly 2,800 extensions installed. Almost 1,000 DCT phones. It takes around, 30 seconds to a minute, maybe 5 minutes to register one DCT phone. So we sat there 4, 5, 6 people registering the DCT phones. All the rest was installed automatically, but 1,200 GSM phones and 300 SIP extensions. On the right side, you see the technology is, so the 4400 again, then Linux core root. If you're really interested in ISDN routing and software, you should come up to the POC. The main developer is right next to the POC. Then we used Yate as a stable SIP server and a bit of Asterisk, and lots of more software and hardware. Some of the software is available on pocapps.sfnet if you're interested. I think that's it. Thank you. Are there any questions regarding the phone network?
How many calls were made?
Okay, the question was how many calls there were. And, well, it is a hacker congress, so we don't have any log files at all. I can't tell you. What I can tell you is we've had 40 DECT antennas to cover the whole area, and the SIP was totally unencrypted. There was only one single person asking for encryption on SIP. Okay.
So as we are the video operations center, we of course have our slides in 16:10 and not in 40:3, but yeah, we come to that point later.
Okay. All right. So this year we changed our. Well, the VOC was composed of 2 different teams. The FEM, who did the congresses of the past few years, and a group of CCC people. And we worked together on doing talks and recordings to you. So we had a new team, and we were distributed all over Germany. So it was rather difficult in the before the Congress to organize ourselves. We had around 20 people, and we had almost 2 full months in which we didn't have any real lives. And
on Mondays.
At least on Mondays when we had our weekly Mumble meetings, which took 3 or more hours each. We filled 40 Etherpads with planning stuff and met for 1 weekend in Berlin to prepare all our infrastructure and test stuff. So we simply, well, we hoped that we could just pack up everything and unpack it on the Congress and it would work. But as you all might have guessed, it's not always that easy. So, well, we thought, let's try some new stuff. Of course, as you all have noticed, we had 1 more track this year, which was, well, 4th of more work to do. But that was relatively easy, so we decided to try something else and upgrade Hall 1 to HD. We weren't really sure if it was going to work, but in the end it turned out to work wonderfully, so you will get all the recordings, hopefully, well, most of the recordings in HD too. And yeah, Also, we changed our setup a little bit, so it's more decentralized. So if somebody stepped on a cable in a hall, it wouldn't affect the recordings anymore. There was also a subtitling team, but we'll have a slide about that later. As in the last years, we offered recordings to the people who
Yeah, actually, last time we only recorded one workshop.
Yeah,
The system, we try to increase that number, but you will see how many recordings we will publish. Or, okay, we land, for example, the noises where people will land a camera and they will publish the recordings.
Yeah, so for the next years, we'll try to increase our workshop recording percentage so that we can also supply you with recordings of the workshops. And we also upgraded our releasing platform. You might know Media CCCDE, and the whole backend was rewritten before the Congress, which also resulted in some fun effects, but we'll talk about later. So that's a slightly more abstract view of how our infrastructure looks like. So on the left, we have the different halls. But the picture you see here is only the halls which are not hall 1. We'll have a picture about that later. And in the middle is our co-location, which is up at the video regie, where we are based. And yeah, and the releasing infrastructure. So
Wait. So and as you see here with the not so different colors, the SDI is some video protocol, and we use it only from the camera to the encoder cube, and from the halls up to everything else, it goes over Ethernet. So
well, and yeah, thanks to NOC for providing us with Ethernet on day -1 already, so we could test all the stuff, and that was really great. So
yes. To my part, I was we had different sub teams. One was responsible for deploying the actual video hardware, cameras, and so on at the halls. We called the system Saal AV, and yeah, let's go into the thing here. The setup here is our standard setup, which we use at smaller events. Just use software called DV Switch, which runs on the mixer left upstairs. There's an encoder cube, and there's also a frame grabber, which actually grabs the slides and brings it to the stream. The cameras are connected via SDI. We have some PCI cards from Blackmagic, DeckLink mini recorders inside of these boxes, and everything works something like that. But we had a different setup for Hall 1. So basically, this is some control. As you see here, we had, okay, mouse not working. We had 3 cameras. We have a Panasonic HG HMX 100 hardware mixer, which was capable of mixing HD, and you just plug one monitor in and not several big ones for each camera. So only one with a multi-view. You see all the cameras and can select which camera do you want. And this goes out on the program. We inject the audio because we don't want the video entries to disturb any audio, because there were some big mixers on the mixer, and this goes up here. And then we had a split setup in Saal 1. The encoder cube from us just did the streaming, and the Ron box from the VEM guys did the recording. And also it was possible to switch the cameras to the beamer switch, which was connected to the beamer, and also to some DVI broadcaster, which we use. This is frame grabber from the former slide, which we use here only for the slide streams. And of course, it goes back into the video mixer, so we can also show you the slides in the stream. So the box we saw currently was this little thing here. It was embedded in the CCH rented hardware. So basically we had a DVA port on the stage this time, which in this case is this box here, which DVI in, fiber out, and work quite nice. But the speakers often didn't use it. I don't know why, but if it says here VGA ports, they simply plug it in, and you get shitty pictures. Sometimes it's a wrong aspect ratio. for that reason, we ordered some, let's see here. We ordered something like this. This is a special PCB which simulates some resolutions. Limits and resolutions because we have only this HB or GPHB connections here. And so it worked quite nice because on Linux and macOS you can select the resolution freely because macOS thinks it knows better for you what to do and what not. Yeah. But also Linux, you have to type some outlines. Thanks to Dattenwall for doing these PCBs, and you can also find up the hardware and the source code at GitHub, and yeah, there's also a wiki page for that. Okay.
All right, so now we've seen how the video gets captured and transmitted to our data center, which was next to the video regie in a wonderfully cozy staircase, which got quite warm over the last few days. So this is our rack where all the streams and recordings are processed. And, well, the cabling is a little bit ad hoc. Anyway.
It only has to last for 4
yeah,
days.
exactly. Nothing is more permanent than a temporary solution. So, well, it worked quite nicely. So this box runs all the streams, and then they get distributed to the streaming servers, which are on the internet. So that's our CDN. I think it's very blurry. But anyway, so we had a lot of boxes which were on the internet. So these are. Yeah, thank you. So we had quite a lot of boxes which you can see on the right there, which were external relays which are donated by various people. Thanks to all of them, you can find. We don't have a sponsor slide sadly, but we have a list on the wiki sponsors. Thanks for that. And they supplied us with, I think, about 23 external relays which helped to distribute the load for the stream viewers, so you could all hopefully enjoy streams without too much interruptions. We had one main relay, which was one external main relay, which was tasked with distributing the video to those edge relays, which the actual viewers used. And this was the rack you just saw, which transmitted the video to the main relay. Well, yeah, and we had one internal box, which was called USA, because it was originally, well, we hoped to ship it to America to have a little bit of geo distribution, but that didn't turn out to be the case. So we had various boxes with names of cities and countries which never matched the actual country or city they were located in.
For example, our server Amsterdam is at Düsseldorf.
Yeah. So this box USA did the HD streams. Well, we'll see about that later. So we used two main components, which was Nginx RTMP, which is an Nginx module which can distribute RTMP and generate HLS streams, which was quite a pain to get running without seg faulting every few minutes. But in the end, we got it to work quite stably. And we also used IceCast for WebM streaming and the audio-only streams, which is incredibly stable. It crashed once because we used a beta version on some of the nodes. So that worked really well. So we did some statistics. You can see peak FIFA right there. So that was only the box inside the CCH, which did, so the HD streams which you could have watched were only distributed from in here. So we had no external relays because the NOC told us to use more bandwidth. And as you can see, we did.
And you didn't
so
do it, yes.
Our peak traffic from inside here was 5 gigabits. So we contributed to those 10 gigabits quite nicely, I think. All in all, we had on the external relays, so not well, including HD, we delivered about 35 terabytes of streams to external viewers and internal viewers too. And of those, only the more than half, more than 2/3 actually, 23.7 terabytes were only the HD streams which we sourced from in here. So we had those 24 streaming relays, and peak FIFA were about 10,000 viewers or even more. And on average, we had 4,500 to 6,500 viewers. Well, operations, we had a sub-team which was tasked with operating all our 96 hosts, which were on-site, off-site, etc. We had 96 hosts and over 2,000 Nagios checks, and we puppetized all the things, so we could just boot up the Congress with a single command line, which was quite fun. And you can see our work weekend, which we had in the beginning of the month. We wrote about a couple thousand of lines of Puppet code. That was quite intense.
So you're now a Puppet master.
Yeah, we are all our Puppet masters now. All right, so recordings and releasing. When I made the slide, which was around noon today, we had already about 62% of all talks released in one of the formats. We'll focus on getting all the talks released first before releasing all other formats, so you can start watching as soon as possible. Hopefully the rest will be released today as far as the talks have already happened. So the releases are going to be MP... Thank you. So the releases are going to happen in MP4 AVC for the HD releases and the HQ standard PAL definition releases. And we've also got a constrained baseline MP4 H.264 for mobile devices and iPod stuff things.
Yeah, it's actually a historical reason why we call this format iPod. I think it was a spelling failure at the beginning, but...
yeah, it has stuck for quite some years, so we call them iPod now. We've also got WebM releases, Opus, and MP3 for audio only.
And
so
just one thing, what you see on the right here is a screenshot from our release tracker. So all the blue bars have to go to the right, and then we are done.
Yeah, it's quite awesome. You just press a button and everything happens automatically. Automation will be a thing in a second. So I just spoke of the subtitles before. There was an awesome subtitling project.
Actually, it was a team consisting of one person or something.
Yeah,
like organizing the things.
Yeah, exactly. So we had the hope to subtitle all the talks, and that will be ongoing once the recordings are actually released. And we need volunteers for that. Please help out. You can find all information on the wiki page and on the subtitles media CCCD. That would be great if we would have closed captioning for all the talks.
Yep. Basically.
Yeah, and speaking. Sorry, I'm sorry.
So basically, just we have now text in pads, and this has to be synced to the video. And the web page you're seeing there uses some service called Amara, where you can do that. So if you have time, if you're driving home and want to watch some video, maybe do it with benefits for others. Thanks.
All right, so speaking of volunteering, nothing, as it goes for the whole Congress, but it also goes for the video team. Nothing could be done without awesome help from the angels. We had 118 audio-video angels, which did the cutting and the mixing of the videos, and 9 coordinators who supervised the halls.
Yeah, this was actually a new thing we introduced on day 2. So not us from the core VOC team have to go everywhere if some speaker is not able to connect his laptop to the beamer. And the angels helped us here, and I think we will continue this on the other events too.
Yeah, we had a lot of heralds, and also the live translation team, which translated all German talks into English, which is great. And also many of the, also quite some of the English talks which are translated into German, and the releases will contain translations if there were any. And an unknown number of subtitlers who already subtitled quite a lot of the videos. So there were some fuck-ups. During the opening event, our recorder mem-leaked quite a bit and fell over, so sadly the opening event will only be released later. Hopefully, we were trying to do it as soon as possible, but it might not happen today. Also on day one, some of you might have noticed an audio outage in the HLS stream. That day I learned that you can actually create an AAC stream without any audio channels in it, so sorry for that. There were some network outages, which we heard about before. They also affected our streams, of course. And yesterday in the evening, we tried to delete one talk, which we accidentally released. And the new media CCC API, which I spoke about before, had quite an interesting bug, which resulted in all the videos being deleted. So sorry for that, but everything's fine now. We are re-uploading them. So yeah, that's
one last thing, we forgot something to remove something from the beginning of the talk. Basically, these are all our devices for
Yeah, we're using the, in case you're wondering about the Winkelkatzen, we're using them to, in the beginning when there are no talks and we are trying to set up the streams and seeing if everything's running, you can't do quite anything without something moving on the stage because, yeah, you don't see anything. So we bought those waving cats and we forgot to put it down, but I think Tim quite enjoyed them, so it's all right. Thank you.
Any questions? Any questions? Nobody? Yeah, just take the microphone. Can you take the microphone? Can you enable the wireless mic for the signal emitter, please? Okay, so you have to switch it on.
Hi? Okay.
Yeah.
I've got one question for the POC. People are complaining that they couldn't call Netherlands. Why?
Can you repeat?
People are complaining that they weren't able to call outside to the Netherlands.
Okay, so is this a question for the POC?
Yes.
It should be possible to call to the Netherlands.
Okay.
Please try again.
And now I have a question for the WOC. Will there be HD videos for talks not in room 1?
There will be only HD recordings in hall 1, yes. In the other halls, there are no HD recordings.
Okay. And
HD is for us 1080i, or no, 1080p. It's confusing, yeah.
And you told that workshop recordings, where could people find them?
They will be uploaded to, as well as the other talks.
They are not uploaded right now?
No.
Okay. And
they will follow later.
Okay, thanks. That's all.
Hi, we're Maylene Kronemann and Sebastian Schum speaking for the Seidenstraße Operations Center, SOC. And with 14 stations and 1.4 kilometers of tube laid, we can't find the Power Operations Center, of course. But we definitely beat the NOC with our 1 terabyte capsule. So we have more bandwidth and lower latency than a NOC. And our average uplink packet size was about this. Speaking of funny capsules,
So as you might seen already, among the payloads we've observed, there's also an onion, but I'll get to that in a minute. So, as we expected, there was a wide variety of payloads that have been shipped with Seidenstraße, like cameras. You can find a bunch of videos on YouTube, in-tube footage. I don't know actually what's so interesting about it. You only see this yellow tube all the time, but okay. I think the Raumzeitlabor shipped popcorn with it quite successfully.
I found a capsule.
Another team, I don't know who actually shipped alcohol. I will get to that on the next slide. And of course, this morning when I just had started doing the slides, somebody came to me and said, hey, let's take a picture of this. And he had a capsule with an onion inside. And I said, that's not how onion routing works. And actually, they implemented the onion routing scheme proposed in the wiki, that you put multiple labels on a capsule and then route it around multiple times. So this capsule went from Seabase to the Bällebad, then back to Seabase, then to the Coffee Nerds, and then to Halaha in the phone booth somewhere. So another interesting thing I've seen, I don't know whether it was used on the real track or only on the test track. Somebody built a capsule with its own air source. So they put an impeller for a model plane inside, and then they used an RC transmitter to move it around in the tube.
There's actually a video online of that on one of the outside roads.
Okay, so again, go to YouTube and look for videos.
In-tube.
And look for in-tube footage. So, yeah, I've got a few pictures. So there's the onion, of course, and the multiple labels. And on the right-hand side, you can see the poster where they said, okay, call us entdeckt, tell us where you are, and we'll send you vodka.
Thanks to Raumfahrtagentur.
And also on the bottom picture, this is a capsule I found, and it didn't get rerouted for some reason, and I put it in a tube and it worked fine. So yeah, it was certified, so it had to, even though you wouldn't think that this thing goes anywhere. So, but yeah, over the days, I've seen more, let's say, improvised capsules. I really hope for a lot of cool 3D printed capsules, but actually most of them look like this. So for the next time, please do cool 3D printed capsules. Can't be so hard. So, so I think you've all read the paper where they said you can bend a glass fiber and then you get photons out of that band to intercept stuff. So someone tried the same here. I don't think it worked. Also, he picked a track in the hack center, which someone rebuilt into a huge round track to do speed testing. So there was not even interesting traffic going on.
Speaking of the loop, there was one highly illegal speed test with 5 vacuum cleaners. And then somebody put a mate bottle in it. What could possibly go wrong? So at the first curve, when the pipe went into the curve, the mate bottle just went straight for, I think, around 7 meters.
So, important lesson here, don't put a mate bottle inside, and if you do, use less vacuum cleaners.
And we did mean it serious. No mate bottles next time, please.
So, yeah, on day 2, I started to put out lists, or I call them transmission logs, on all switching nodes so that we can get a rough estimate about how much capsules actually routed. And yeah, I walked around this morning, collected the results. And as you can probably guess, some logs were really accurate, and somebody made a mark for every capsule they routed, like for example, the Hauptfoyer or Erster Stock, and others like Assemblies 1 or Seabase. I don't think they marked all capsules going through, because at least for Seabase, I know there were a lot more. And yeah, as you can see, overall, we've received over 480 capsules, and we've sent about so I think, as you can see from the numbers, most stuff has just been sent from one end to another, possibly. So, and then there was this other little side project, because telling people to make marks on a piece of paper is somehow so last century, and we thought, okay, this is a hacker conference, we need to come up with something cool. So we started a project called Zählrohr, like the thing that, or Zählrohr is the German word for this tube you use to measure radioactivity. And it also means, so if you translate it directly, it would be a counting tube. So I thought this was an accurate name. And we actually planned to deploy one Zählrohr at every switching node, but you know how stuff works. So you plan this project. Actually, I planned it from Kaiserslautern with Chaos in KL, and the other end was Munich, CCC in Munich. And we did like 1.5 months of planning. We etched 25 boards, I think. We organized microcontroller boards. We organized Raspberry Pis. We had everything ready, and when we plugged it in here, nothing worked. So what we managed to get working was this one station at Seabase. And short side note before I go to the next slide. Everything we did is open hardware, so go to GitHub. I've put the URL on the slide. You can find all schematics, the software, and everything. So what we did manage with this single station is we brought you regular capsule updates on a big flip-dot display, which is just outside of this room. You might have seen it. First, we said, okay, we only use a small part of the display so other people can play with it. And then several people complained there is a typo in the messages. I think most people should have spotted it by now. And also, you can't read the name of the endpoints because I've got only so few characters. So we did an updated version, big thanks to the guys from Munich again. They helped me a lot in integrating everything. And then we could display Seidenstraße updates full screen. Also, I did some data mining. I know this is a hacker conference. We should not log too much stuff. But I thought, okay, I'm logging only metadata. This has to be safe. So the fastest capsule that we've encountered was like 11 meters per second. It came from Erster Stock, and it went to Seabase. So it had gravity and the huge vacuum system they had at the Seabase node. So yeah, it was really fast. And it made a nice boom when it arrived. Also, I've looked for the slowest capsule. There were quite a few really slow capsules because people kept pushing them really deep into the tube with the hand, and then you get the other end of the scale with like 0.5 meters a second. Not really interesting. But it's also important to know I got the speed measurement working on the 28. And people noticed it, and they started playing around with it, and so they set the speed record on that day. and afterward no one was able to break it again. So I think I've underestimated you folks here, because I thought, okay, maybe on the first day some slow capsules, and then they get some experiments, and then they know how to build faster capsules, and maybe I'll get the fastest on the last day. No, I got the fastest on the first day of deployment, so well done. Another thing, average speed was 2.7 meters, which is again because people kept pushing the capsules with their hands inside the tubes. We got lots of really slow samples, and yeah, so the fast samples are a bit evened out.
Also, the speed depends a lot on the capsule design. So smaller capsules don't get easily stuck, but they're slower, of course, because they have less pressure.
Yeah, of course. That's another point. So, and in the end, you know, the first slide I did with the results on the paper list, and here I've got the results that the automatic counter got for Seabase, and yeah, let's say it's a bit more. And yeah, some capsules might have been measured double because they got stuck and you had to suck them back again and then pull them, yeah, push them again. But I think, yeah, it's an accurate number at that point. So you may want to do your own data mining. I've uploaded all the data I've collected so far as JSON files. You see the URL down there. It's also documented in the wiki, and there you get raw samples, and I'd really like someone to do a nice visualization of some kind. So if anyone here in the audience wants to play with a huge pile of JSON files, feel free. Yeah, and that's all from my side. Questions?
Yeah. So I don't have a question, just a quick thing that we tried. We tried using the tubes not for transmitting capsules, but for transmitting sound. That works really well. And we were able to transmit very small, like low bandwidth data over it. So any ham radio operator that's in the room may know PSK31. That works really good. Morse code also works really well. We were trying to send a raw image, just like piping a raw image file onto our sound card and then transmitting that. That works somehow. We can see on the other side, you can see some of the images, but it's not really working as well. And I've seen at least one picture transmitted over the SSTV, slow scan television format. Also something that's coming from ham radio by the Karlswelle assembly. So there might be an interesting side channel that we can use in the future.
Fire door breaches. Okay, the question was if there were any interesting ways to route around fire doors. So I think...
Well, there was a concept to build a line follower to do the transports between the entrance, no, not the entrance hall, between the Erdgeschoss foyer and Saal 3. But it was not finished in time, unfortunately. Next year. There were also concepts about flying capsules, so it would have been Wi-Fi Seidenstraße. But I believe there were some safety issues. I told you about the first experiments with the flying metal bottle. So.
There is one question from the internet. I'm here. Why were the tubes yellow? They want transparent ones.
Sorry, can you repeat the question? There was a bit of noise out there.
Why the tubes were yellow? They would like transparent ones.
Yeah, I think yellow is, these are standard tubes for draining water. So they are yellow because I think the plastic is yellow and it's cheaper than making them transparent. And I don't know, actually, I don't know where to get 1 or 2 kilometers of transparent plastic tube. Might be interesting to find that out.
Thanks.
Ich bin zu klein. Ach so. Did you plan to integrate the Seidenstraße into C3 Netmon?
Yeah, we, or at least I thought about that in the beginning, but then I thought, okay, most of the coding on this project was done by me, so other people provided hardware, but I was writing all the code. And then I checked what I had already running, and then I thought, okay, now integrating with the network monitor, yeah, it was simply too much work and too much complexity. Maybe next year.
Okay.
So,
how did you ship and store 2 kilometers of drainage pipes?
We just ordered it and had it shipped here.
Yeah, but how many? How much place is accompanied by? Yeah, do they come by an LKW or?
It's not that much. It's only half a jumbo truck.
Okay,
So
I thought it was more.
But actually, it was quite difficult to get 2 kilometers because most of the pipe producers go on Christmas holidays really early. So, and we did have some problems with the logistics. For example, the rope we ordered didn't arrive at all, and I had to go and buy some at the Tauwerkfabrik 1 day before Christmas. So that was like 1.2 kilometers. So I was really lucky they had that much in stock. And also the delivery was a bit messed up, so they delivered the wrong adapters. So we had to improvise something. Thanks to Till for that. Yeah.
Oh, there goes the slide. So, any further questions or?
I think we have still some team.
Yeah, the
Oh.
What do we need?
Well,
So if anyone of you was wondering what that noise was, that was
Test. Test. Yes.
about
Okay.
40 boxes of empty mate and other bottle cases falling down the ramp.
This works.
Flying mate bottles, but empty ones, and not in Seitenstraße, luckily.
Yeah. Thanks. All right, so this year we had a GSM network again. This year, as opposed to last year, we did not use any OpenBTS systems. That was an excellent experiment last year, but this year the OpenBTS guys weren't here, so we went back to running only the OpenBSC network that we've done a couple of times. We had 7 base stations. Well, we still have 7 base stations deployed throughout the CCH. We're using 2 kinds of base stations, the Sysmo BTS and mostly, and the Nano BTS in a few places. We were using some BTSs with 3-watt amplifiers, which is also the maximum output power, transmission power that we were assigned. And we were using some BTSs without amplifiers, where they have quite a bit lower transmission power, which was fine. For example, out here in the entrance hall, in the lobby, and I believe in Saal 1. We had SIM cards this year, pretty nice SIM cards. Unfortunately, too few SIM cards. Sorry about that. I know that many people wanted to get more SIM cards, and that probably many people didn't get a SIM card who wanted one. We'll try to fix this for next year and have even more of them. We had 1,000, and they sold out in the afternoon of the second day that we were selling them. We had some interesting issues. We discovered that German Vodafone answered. So when a cell phone has a SIM card from one of the C3 SIM cards, and it, for whatever reason, tries to contact Vodafone, as phones do, whenever Vodafone is the strongest, has the strongest signal, the cell phone goes there and tries to do a what is called a location update, basically registering to the network and saying, I'm here, may I use the network? Vodafone, they replied back to the phone, the SIM card does not exist in the HLR database, which sounds reasonable at first, but what it means for the phone is that the phone stops trying to register to the network, because it's been told that, well, actually, you don't exist. So that's bad for us, because then the phones, when they see, even if they see or if they come to an environment where the actual Congress network is the strongest, they still don't register. So there was a mass SMS sent out, and many of you got your SIM cards updated with Vodafone added to a block list, so that the C3 SIM cards do not try to talk to Vodafone anymore. It would have been much, much better if Vodafone had replied, I don't know who you are, instead of the permanent error, you don't exist. But oh well. I guess the motivation behind that is that there is really only one GSM system. It's global, after all, right? So, well, whoever they don't know doesn't exist, I guess. We have a bit of statistics to show, device statistics, first of all. So let's see how this works. Yeah. There are two addresses, tinyurl.com/gsmstats and /gsmdevs. So this is the GSM devs page, showing number of devices per manufacturer that the network has seen. This doesn't mean only the devices that were used with C3 SIM cards, but it also includes any devices maybe passing by in trains that found a strong signal, although I don't think there was any on the back of the building, or outside in front of the CCH and whatever, people walking by nearby, where the phone would, for a brief moment, think that the C3 network was the strongest. Of course, we didn't do the Vodafone thing. We're a bit kinder, so we just say that the temporary error, and those phones will try to connect again to their home operator once they move out of the way. We see that Samsung seems to be by far the most popular. The Nexus B5, and Nokia is good as well. There's this, LG. 350 of those, and only a few of the others. What else? Apple. Lots of iPhones. iOS devices, I should say. iOS machines. And let's see, the other one. Oh, okay. Oh, well. Yeah. So this is the C3 Netmon. Maybe you've shown it already before. Let's see if there's, yes, GSM, here we go. No, no click. All right. So a good number of SMSs sent, 14,000. SMSs delivered, 15,000. That's interesting. Calls issued, 8,100, and calls delivered, 3,200. I can explain the difference in calls. I'm not sure what's up with the text messages. Yes, oh, right, okay, SMS delivered. It could also be that there were multiple, that the first delivery attempt didn't work, and the text message is then, of course, still in the queue, and eventually, so the network will then retry to deliver this text message, and eventually it succeeds, and then, of course, that counts as multiple delivery attempts. The calls issued and calls delivered. Calls issued is calling from a GSM phone to anywhere, could be a DEC phone, could be apparently also outside of the conference network, the conference phone network. And calls delivered is calls to cell phones, of course. So I think this is quite a good increase from last year. I don't remember it being at all that many. And yes, that's what I have to say. I'm happy to answer any questions.
I would have. Go ahead. A couple of things. That SMS message you sent out to tell the SIM cards to block the Vodafone network.
Yes,
is that something that requires user interaction to complete, or was that something that just happened behind the scenes?
Yes, no. So this year, the SIM cards that we have been using, they are not over-the-air updatable. They are not. It's not possible to send an update out via SMS. These SIM cards are a little bit simpler than the typical SIM cards that you get from a real-world network. The real-world network SIM cards, they all have software updates pushed to them over the air on a regular basis. But we couldn't do that here. So yes, it required user interaction. A lot of people stopped by our room and had their SIM cards upgraded with this new block list entry for Vodafone. So yes, that requires user interaction or well, yes.
And the other thing then is that, is it possible to configure a BTS to respond to location update requests to tell any SIM to go away that it doesn't exist? Because that's an opening there for a serious denial of service attack, no?
Yes, it's trivial.
Okay. Hey,
Do you know anything about the range of our network? Because in this morning, one cell phone in our hostel still claimed it had reception of the network, which is some kilometers away.
No, that sounds like a bug. I didn't do range testing myself. I'm surprised if we have coverage even over the entire park outside. The base stations are placed to cover the building areas where people move around. Primarily, the base station inside the lecture halls, well, inside lecture hall 1 and 2, they had a shorter range as the one in the lobby here, but they were still. Well, that's also maybe interesting. They were constantly overloaded, the ones in the lecture halls, by people listening to the translation streams, which is fantastic. That's why we're doing the network, but we're may try to experiment with an optimization there so that we can do some kind of broadcast audio for certain phone numbers. Let's see if we get that to work. And it's not quite standards compliant, but maybe it will work anyway. Let's see.
Yes, will the cards be reusable on the upcoming events?
Yes, just like all the old cards just like all the old cards have worked at previous events and also have worked at this event, the cards you got this year will continue to work in future test networks that we run as well.
And I have a question to the Seidenstraße project. What are you going to do with the 2 kilometers of tube?
Is this thing on? Yeah. So the question was, what are we going to do with the tube?
Oh, I'm just organizing this at the moment. That's why I'm not listening. Frank organized that the deliverer would take the tube back for the symbolic price of €1. But we can keep all the pieces that are not rolled up anymore, I think. Just waiting for a reply now. So we can definitely keep the short pieces. So if you want to build a test track in your hackerspace, yeah, you can take as much as you like.
Okay, I don't see any more questions. If you have one, hurry up. 3, 2, 1. No, that's not the case. So then, thank you very much for your talk, and thank you very much for making this Congress that awesome and even possible.